So figure 10.1 shows a battery with the EMF of 12 volts. And as you can see, lamp 1 and lamp 2 are connected in parallel. If this is 12 volts, what is the voltage across L1? If the voltage of the battery is 12, EMF is 12, what is the voltage across L1? They are connected in parallel. So this will be 12 and this will also be 12, because in parallel circuit, what are the characteristic of the parallel circuit? The parallel circuits, they will have same voltage and the current will divided current will be there. Calculate the current supplied by the battery when both lamps are on. So figure shows a battery with an EMF of a 12 and the total power is 150. So we have the formula P equals VI. So total power is 150 and the total voltage is 12. So 150 divided by 12. What's the answer for the current? We'll get current as 12.5. So this will be 12.5 ampere. So means from the battery, how much current will flow? The current which will flow in this circuit, that's equal to 12.5 ampere. Now this 12.5 is moving. The current in lamp 2 is 5. So out of 12.5, 5 ampere will flow through this one. How much current will be here in lamp 1? If total is 12.5 and proportion of 5 ampere out of 12.5 moves through lamp 2, how much current will flow through lamp 1? So we simply subtract. It will be 12.5, the total minus 5. So how much we get? We get 7.5. Because we subtract. Why we subtract? As the total current divide. Like the total current was 12.5 when we calculate how much current is in the circuit from the battery. So the total was 12.5 ampere. Out of this 12.5, they mentioned 5 ampere is moving through lamp 2. So remaining will flow through lamp 1, which is how much? So 12.5 minus 5, which is 7.5. So the current in lamp 1 will be 7.5 amperes. The power of the lamp 1. So how to work out the power? Power is a product of voltage and current. P equals VI. So what is the voltage of lamp 1 across lamp 1? That's 12. And how much current is there in lamp 1? That is 7.5. So it will be 12 multiplied by 7.5, which is equals to 90. And the unit of the power is watt. So 90 watt is the power. Then the last part, the resistance of lamp 1. If we need the resistance of lamp 1, resistance is a ratio between voltage and current. So I'll solve here. Resistance is a ratio between voltage and current. Voltage across lamp 1 was 12 and the current across lamp 1 is passing through lamp 1 is 7.5. So it will be 12 divided by 7.5, which is 1.6, and the unit will be ohm. So we write this as omega. Is it clear, this question?
Yes, sir.
So what we did here, we used the understanding of the circuit plus the formulas. So you need both of them. Like you have to recall, like what happened in series circuit is the current is same, the voltage will divide, but in parallel, the voltage will be same and the current will divide. Then you have to recall the formulas like V equals IR, P equals VI, E equals VIT. And these formulas are very common. P equals VI or R is equals to V over I. This is a very common one. We use like many times these formulas. The next question. The heater is powered by a main supply of 240. So they are all connected in parallel. So if this is 240, how much voltage will be there across the motor? 240. What is the voltage across R1? 240. What is the voltage across R2? 240. Because they're all connected in parallel. Separate connections, different current. Switch 1 and switch 2 are closed. So we close this switch and we close this switch. Switch 3 is not closed. Calculate the current in the heating element R1. So we need how much current will flow here. We already know the voltage is 240. And we know its resistance dimension, the resistance is 30 ohm. So to find the current, we have the formula V equals IR. So if I need the current, voltage is 240, current we don't know, and the resistance is 30. So 30 is multiplied, other side divide. So 240 divided by 30, that's equal to 8 ampere. So 8 ampere is a current flow through R1. Calculate the power produced by R1. How to get the power produced by R1? Again, we use a formula P equals VI. So voltage across R1 is 240 and the current in R1 is 8. So 240 multiplied by 8, that is 1920. And the unit will be ohm. The resistance of a heating element is 60. R2 is 60. Oh, sorry, not ohm. It's a watt here. By mistake. So P equals VI and the power is should be in watt. The resistance of R2 is 60. State and explain how the current in R2 compare with R1. Like if I say R2, like we close these switches, the resistance of R2 is 60 ohms and the resistance of R1 is 30 ohm. Which component, which heating component will have more current, R1 or R2? Which will allow greater charges to flow through it?
R1.
R1. Because, so state and explain how current in R2 compare with R1. So, or you can say like the resistance is like for R2 resistance is double. So the current will be half compared to R1. Or R2 will allow low current compared to R1. So the current in R2 will be less, or you can also say half of R1. Why I'm using the term half here? Because if you see the resistance is double. If the resistance is double, the current which will flow, like if I say when we calculate this current, it was 8 ampere. So when we calculate this current, it will be 4 ampere. It will be half. Is it clear? This question related to the circuit? Anyone having a question or doubt in this?